I have to admit, before digging into all this research, I had a pretty uncharitable view of newborns.
Oh, yeah.
I mean, I love them. They're cute. But I always kind of saw them as, well, passive blobs. You bring them home, they eat, sleep, scream, and poop. It felt like you're just keeping a biological machine alive until the personality update downloads a few years later.
That is the classic misconception. It's so easy to think that way because they look completely helpless.
Right.
But if you actually look at the data, and we've got a lot of it here, that so-called blob is actually the hardest working scientist in the room. From the second they take that first breath, they're running these complex physics experiments, decoding sensory input. It's incredible.
Which is exactly why we're doing this deep dive today. We are decoding the operating system of the human infant. And this isn't just about parenting tips. This is the origin story of you.
Yeah.
We're looking at how you went from this helpless creature that couldn't even lift its own head to a person who can understand that I have thoughts different from yours.
It's a phenomenal journey. We're going to look at the hardware, the reflexes, the physical growth, and then the software, all those cognitive leaps. But the real mission here is to answer that one huge question. How do we bridge that gap?
How does an infant achieve more in 4 years than most species do in an entire lifetime?
Exactly.
So let's start at launch day. Day 0, you're born. You can't talk, you can't walk, you can barely even focus your eyes. But you aren't a blank slate, are you? The research shows we come with some pre-installed software.
We absolutely do. We call them reflexes. And I think a lot of people just dismiss them as, twitchy baby things. But they are highly specific, automatic responses to stimuli. They are the survival kit.
The eating ones make sense to me, like a rooting reflex. You stroke a cheek, they turn their head. That's just find the food.
Right. Rooting and sucking are the keep the machine fueled protocols. You put something on the roof of a newborn's mouth, and they will suck. They don't have to learn it.
Yeah, if they had to learn that, we'd be in trouble.
The species would have died out a long, long time ago.
Okay, so survival I get. But what about the weird ones? I was reading about the Moro reflex, and it just seems so dramatic.
Oh, it is. It's that one where a baby gets startled, or maybe their head drops back just a tiny bit.
And they just fling their arms out wide and then hug them back in.
Exactly. It looks like they're trying to catch a beach ball.
So what's that about? Why do we have it?
This is where we have to look at our evolutionary history. The leading theory is that this is a remnant from when we were primates.
I mean, like monkeys.
Think about a baby monkey clinging to its mother's fur while she's moving through the trees. If that baby loses its grip, if its head falls back, that reflex is the emergency brake. You throw the arms out and you clamp down to grab the fur.
Wait, hold on. You're telling me that when a modern human baby in a safe padded crib gets startled, they're basically trying to grab onto a mother that isn't covered in fur anymore.
That's the idea. It's biological baggage. It usually disappears around 6 months, which, not coincidentally, is when infants start getting enough core strength to support themselves. The brain basically says, okay, we don't need the emergency clamp anymore. We have muscles now.
Speaking of muscles, the one that really blew my mind was the stepping reflex. I always thought walking was something you learned totally from scratch. But the research says if you hold a newborn upright, they actually try to walk.
They do. If you hold them so their feet touch a flat surface, they'll lift one leg and then the other in a rhythmic stepping motion. It's incredible because it proves the neural pathways for walking are pre-wired. The code is there on day 1.
But, and here's the confusing part, they stop doing it. The reflex vanishes around 2 months old, and then they don't actually walk for another year. So what gives?
That's the mystery that puzzled researchers for decades. Why does it vanish? And the answer turns out to be shockingly practical. It's not the brain, it's the legs.
The legs.
Babies gain weight incredibly fast, mostly fat in those first few months, but their muscles just don't grow as quickly.
So their legs literally get too heavy to lift.
Exactly. It's a gravity problem. The neural signal is still saying step, but the legs are saying, sorry, we're too heavy. We know this because if you put those same non-stepping infants in a tank of water where they're buoyant.
Let me guess. They step.
They step perfectly. The program never left. The hardware just needed an upgrade to handle the new software load.
That is wild. So beyond being cool party tricks, is there a practical use for checking all these reflexes?
Oh, hugely practical. This is why pediatricians are always messing with your baby at checkups. These reflexes are key indicators of neurological health. If a baby is born without them, or, and this is just as important, if the reflexes don't disappear when they're supposed to, it can signal that something might be wrong with the nervous system.
It's the first diagnostic check we have, which reminds me of the literal first test we all take, the APGAR score. I feel like I hear parents humble bragging about this. Oh, Timmy got a 10, but I never really knew what it measured.
It's a triage tool. It's done at 1 minute and 5 minutes after birth. It just checks 5 basic systems: heart rate, respiration, muscle tone, reflexes, and skin color. You get 0, 1, or 2 points for each.
Oh, a 10 is perfect.
A 10 is actually pretty rare. Most babies have slightly blue hands or feet at first, but generally, anything over a 7 means this baby is handling life outside the womb well. Anything under 3 means emergency. We need to intervene right now.
So, assuming we pass the APGAR, we go home, and then the real work starts. And by work, I mean sleeping.
Lots and lots of sleeping, 16 to 18 hours a day.
But there is a scary side to the sleep discussion. We have to talk about Sissy's sudden infant death syndrome.
We do. It's every parent's worst nightmare. A healthy baby suddenly dies during sleep, and we don't always know why, but the research has given us some very strong clues. It seems to be linked to brainstem development.
And the brainstem controls all the automatic stuff, right? Breathing, heart rate.
Correct. The theory is that some babies might have a slight abnormality where if they get into too deep a sleep or their airway gets a little bit obstructed, the brainstem just doesn't send the wake up and breathe alarm. It forgets.
That is terrifying.
It is. But that understanding changed everything. And that's where the Back to Sleep campaign came from. Just by putting babies on their backs, we drastically reduce the risk of them getting into that compromised position. It's a perfect example of how understanding the biology saves lives.
So while they're sleeping those 18 hours, what is happening upstairs? Because the physical growth is obvious. They triple their weight in a year. But the brain growth is invisible.
Invisible, but absolutely explosive. At birth, your brain is 25% of its adult weight. By age 3, it's 80%. That is the fastest growth you will ever experience.
But what does growth even mean here? Are we just stuffing more cells in?
It's not just more cells. It's about connection and speed. So first, you have myelination. Imagine a bare copper wire. The electricity leaks, the signal is slow. Myelin is like the rubber insulation. It wraps around the nerve fibers and makes signals travel up to 100 times faster.
Okay, so faster wiring. Got it. But then I read about synaptic pruning, and honestly, it made me a little sad.
It is a bit poetic, isn't it?
It sounds like we're losing things.
We are, and we have to. When you're born, your brain is hyper-connected. You have way more synaptic connections than an adult does. You're essentially prepared to learn anything. You can distinguish between sounds in languages you've never even heard. You are a universal learner.
So I was born with the ability to speak Mandarin, flawless French, and Xhosa.
Theoretically, your brain was wired to accept those inputs perfectly, but your brain is also an energy hog. It can't maintain connections it doesn't use, so it starts to prune. It looks at the pathways you aren't using, say the ability to hear the tonal differences in Mandarin if you're in an English-speaking house, and it just snips them.
Use it or lose it.
Literally. It cuts the unused side roads so it can pave the main highways into superspeed interstates. You lose some potential, yes, but you gain efficiency. You become a specialist in being you, in your environment.
It's a trade-off. We trade infinite possibility for actual competence.
Precisely. And this connects to plasticity. The brain is so moldable. The research mentions a therapy called BA-TRACK.
The acronym sounds like a Batman villain.
It stands for bilateral arm training with rhythmic auditory cueing. It's actually for stroke patients. They use rhythm and simultaneous arm movements to force the brain to rewire itself around the damage.
So if a 70-year-old brain can rewire itself after a stroke, a baby's brain must be like wet clay.
Exactly. If we can reshape an old brain, just imagine the flexibility of a brain that is still being built. That's why early childhood is such a critical window. The clay is still wet.
Okay, let's talk about how that brain gets its information. The senses. I think most of us assume a baby sees and hears what we do just from a lower angle.
And that would be wrong. Their sensory world is completely different. Take smell and taste. Those are the most developed at birth. There's a crazy experiment about amniotic fluid.
Oh, this one weirded me out.
So researchers took pads, soaked in the mother's amniotic fluid, the stuff the baby floated in for 9 months, and placed them next to the newborn.
And the baby turns toward it.
Every time. It turns its head toward that smell. It smells like home. They also have a massive sweet tooth. You give a newborn sugar water, they relax. You give them something bitter, they make a clear disgust face.
Which makes evolutionary sense, I guess. Breast milk is sweet. Bitter often means poison in nature.
Exactly. But then you get to vision, and it's a disaster. Newborns are legally blind by adult standards. Their visual acuity is something like 2400.
So if I'm smiling at my newborn from across the room,
They don't see a smile. They see a blurry, grayish blob. They can't see color well. They can't focus.
so how do we know what they can see? You can't ask a 3-month-old to read an eye chart.
We use the stripe test. It's brilliant in its simplicity. We know babies prefer looking at high contrast patterns like black and white stripes over a plain gray square. It's just more interesting to their brains.
Okay.
So we show them stripes, then we make the stripes thinner and closer together. As long as they keep staring at the stripes, we know they can see the difference. The moment they get bored and look away, we know the stripes have just blurred into one gray mass for them. That's their limit.
That is surprisingly clever. We bore them into revealing their eyesight.
Yeah.
But what about depth perception? There's a huge difference between seeing a stripe and knowing you're about to crawl off the edge of bed.
This is one of the most famous experiments in all of psychology, the visual cliff.
Describe this for us.
Imagine a table. Half of it has a checkerboard pattern right on the surface. The other half is thick glass, but the checkerboard is way down on the floor, maybe 3 feet below. It looks like a drop-off, but it's totally safe.
An optical illusion of a cliff.
Yes. Now here's the kicker. If you put a really young baby, say 2 months old, over that deep side, their heart rate actually goes down. They're interested, not scared. They notice the depth, but it doesn't mean danger to them yet because, well, they can't move yet. Why be afraid of falling if you can't crawl?
Right. But take a 7-month-old, a baby who has started crawling.
You put them on the edge and they will not cross it. They freeze, their heart rate spikes, they get upset.
So fear of heights isn't something we're born with. We learn it when we start driving the vehicle, so to speak.
In a way, yeah. The fear is linked to motor development. And this brings us to a major update in how we understand movement. It's called dynamic systems theory.
Okay, that sounds a little technical.
It sounds complex, but it's actually very intuitive. The old idea was that motor skills were just a genetic clock. Tick-tock, time to crawl. Tick-tock, time to walk.
But you're saying it's not a clock.
It's a puzzle. Dynamic systems theory says that a new skill like walking is a solution to a problem. The baby has a goal. I want that toy. The baby has constraints. My legs are heavy. Or the floor is slippery. The baby has to reorganize their entire system, brain, body, motivation, to solve that equation.
Well, it's not just brain says walk. It's brain plus muscles plus motivation plus the environment.
All working together. Remember the stepping reflex? The system changed, the weight increased, so the behavior disappeared. Later, when the muscle strength catches up, the behavior comes back. It's all dynamic.
I love that idea of a baby as a problem solver, not just a passenger. Let's shift gears to something less physical. Let's talk about the ghost in the machine, the self.
The big philosophical question.
When does a baby realize, I am a thing that exists? Because if you show a puppy a mirror, it just barks at the other dog.
And for the first few months, human babies do pretty much the same. You put a 9-month-old in front of a mirror, they'll smile at the baby friend, they might pat the glass, they have no idea it's them.
So how do we know when the switch flips?
We use the rouge test or the mirror test. You take a baby, maybe distract them for a second, and you sneakily put a little smudge of red lipstick or rouge on their nose. Then you plop them back in front of the mirror.
And if they think it's another baby?
They might try to wipe the mirror's nose or just stare. But somewhere between 15 and 24 months, the magic happens. They look in the mirror, see the red spot, and reach up to touch their own nose.
They realize the image is a reflection of them.
Boom. Self-awareness. That is me. And once that happens, everything changes. They start using words like me and mine. They start feeling self-conscious emotions like embarrassment or pride. You can't feel shame if you don't have a self-test to be ashamed of.
And that leads to the final and honestly the most mind-bending concept we have to cover. Theory of mind.
This is the big one. This is the realization that other people have brains that are different from yours.
Up until about age 3 or 4, a child assumes that everyone knows what they know. If I know the sky is blue, you must know it too. They can't comprehend that you might have different information. The notes mention the Sally Ann test. I want to walk through this because it perfectly illustrates how weird a toddler's brain is.
Okay, let's do it. So imagine a little puppet show. We have 2 dolls, Sally and Ann. Sally has a basket and Ann has a box.
Okay. Sally and Ann, basket and box. Got it.
Sally puts a marble into her basket. Then Sally leaves the room to go for a walk.
Bye, Sally.
While Sally is gone, Naughty Ann takes the marble out of the basket and hides it in her box.
The plot thickens. Anne is a thief.
So now Sally comes back into the room. The question we ask the child watching is, where will Sally look for her marble?
Okay, for me, an adult, the answer is obvious. She'll look in the basket because that's where she left it. She doesn't know it was moved.
Right. You understand that Sally has a false belief. But if you ask a 3-year-old that question, they will point straight to the box.
Because they know it's in the box.
Yes. They think, I know it's in the box, so Sally must know it's in the box. They cannot separate their own knowledge from Sally's. They assume reality is totally transparent to everyone.
That is fascinating. So they basically think the world operates like a hive mind.
In a way, but then around age 4, something just clicks. You ask them the same question and they'll say, oh, she'll look in the basket. They realize Sally can be wrong. They realize that different minds can hold different beliefs.
And that opens the door for so much human behavior. Empathy, for one. You can't empathize if you don't realize I might be feeling something totally different than you are.
It also opens the door for lying.
True. You can't lie effectively if you don't understand that you can manipulate what I believe to be true.
Exactly. Deception requires theory of mind. So when your kid tells their first really convincing lie, we should be annoyed, but also secretly proud. It means their cognitive development is right on track.
Honey, he just lied straight to my face. He's a genius.
It's a developmental milestone.
So bringing all this together, we've gone from a reflex-driven newborn who can't lift their own head to a 4-year-old who understands social deception and has a complex sense of self. It is staggering.
It is. And I think the big takeaway for me, going back to the very beginning, is how active this whole process is. We aren't just growing, we are pruning. We are actively shaping ourselves.
That concept of synaptic pruning really stuck with me.
It should. And here's the thing to leave our listener with. It never really stops. Yes, it's most dramatic in infancy, but that neuroplasticity exists throughout our lives. We are constantly strengthening the connections we use and weakening the ones we don't.
So in a way, we're all still sculpting our brains right now.
Every single day. What you pay attention to, what you practice, what you obsess over, that is physically changing the structure of your brain. In the same way the baby loses the ability to hear certain sounds, we lose the abilities we neglect. So the real question is, what are you feeding your brain today? And what are you letting wither away?
I think I'm going to go learn a new language before my brain prunes the rest of my high school Spanish.
Probably a good idea.
This has been amazing. Thank you for walking us through the operating system of the human infant.
My pleasure.
And thank you for listening to this deep dive. Go explore your world. We'll see you next time.